Thank you very much. It's a pleasure to be here, and I want to talk a little bit about how the oceans influence life on Earth. What makes Earth different from any other planet in our solar system is the presence of liquid water at the surface. Lots of it. And life, of course. And these two facts are interlinked. Life originated in water, and water sustains life. And what I want to do now is to show you how the oceans are playing a crucial continuing role in supporting life on Earth. So this is how we used to thinking about the oceans as 71% of the surface of planet Earth and 29% of the Earth is land. We're a very terrestrial-centered animal, and we like to think about the land first. But if you take into account the third dimension of the oceans, which is down, then the ocean occupies a much, much bigger amount of the surface of the planet, in fact, or the volume of the planet. So this is 97% of the volume of the biosphere is ocean. Just to give you a sense of how big the ocean really is, this is a little droplet of water. It looks crystal clear, you can't see anything in it, but in fact, inside this droplet, there are 200,000 viruses. Now, viruses are very important to the way that the oceans function, and if you were to put all of those viruses end to end and stretch them into outer space, how far do you think they would reach? Well, when I ask audiences this, I get answers like, well, as far as the moon maybe, some people hazard the sun, other people think maybe the edge of the solar system, but the answer is much, much further than that. They would stretch 200 million light years into space. So not only would they leave our galaxy, they would pass more than 100 other galaxies on their way into outer space. So there's an extraordinarily large number of viruses in the sea. And to put it in more familiar terms, it's equivalent to 175 million blue whales, or 70 times the weight of all of us on planet Earth. Also present in this tiny droplet of water are phytoplankton. These are the plants that live in the sea. They generate oxygen through photosynthesis. They generate food as well. And they are right at the bottom of all of the ocean food webs that are out there. Now, if you look at the Earth from space using a satellite, then you can sense the different colors at the ocean surface. And what's the satellite here has been tuned to do is to pick out chlorophyll, the phytoplanktonic pigment, and you can see from this, the greenest parts of this globe are the areas of richest plant growth. So these are like forests of the sea. And what you can see on this image, it's rather beautiful really, is you can see the seasons changing, moving up and down across the surface of the planet. And it's a bit like the Earth, the oceans breathing. And you can also see the currents that are flowing around the planet, revealed by the presence of phytoplankton. So if you look at the stream across the equator in the Pacific Ocean, you can see this really strong current moving from east to west across the ocean there, and the Galapagos Islands in the east look like a stone in the middle of a river. And those phytoplankton are critical to every ocean food web, as I mentioned, and they underpin all of the fisheries on Earth. And collectively, we catch something like 140 million metric tons of fish every year. It feeds more than 1 billion people. It provides micronutrients to an even larger number of people. So this is a very critical service that the oceans produce for us. So here is the number of people who depend on seafood. Now, the problem that we have for seafood is that the ocean has two layers. There's a skin on the surface of the ocean, and that consists of warm, light water, which floats on top of cold, dense water. So just like a layer of oil on a pan of water. And this surface layer has all of the light, so that's where all the photosynthesis takes place, that's where the plant growth is, but it has few nutrients, which is the fertilizers that the plants need to grow. And the reason for that is that those nutrients sink through this boundary between the surface layer and the deep layer. And so in order to boost phytoplankton growth, you need to mix water up from deep down into the surface. Now we know one major mechanism of this kind of mixing, and that is the physical forces that shape the oceans. Big storms, strong currents, these are things which mix water up into the surface layer and promote the growth of phytoplankton. But there's also another important route to fertilizing that surface layer. This picture was taken off the coast of Chile a few years ago, and it shows a group of blue whales, not blue whales, I beg your pardon, sperm whales sleeping. And if you were diving with these sperm whales and you went up and had a look at the eyeball, you would see the eye moving rapidly, just like our own eyes do during the nighttime, the rapid eye movement. Now, the thing about sperm whales is that they feed deep and they shit shallow. So a sperm whale dives down into the depths of the ocean. It goes into this deep, cold layer with lots of nutrients. It fights the giant squid. Well, actually, most of the squid that the sperm whales catch are relatively small. But it brings the nutrients back up to the surface, and this is called the biological pump. And so here is what happens when the whale comes to the surface. And if you were snorkeling behind this whale, you'd really get caught in a shitstorm, I think. The important thing about that is that this whale poop is full of nutrients that are important for fertilizing the phytoplankton. So this pump is bringing nutrients up to the surface, and it's really important for sustaining ocean food webs. Now, there are other animals that do much the same kind of thing. Here is the most ferocious shark in the sea, the great white shark, and they dive down deep as well. They feed deep and they come up and poop shallow. They also feed shallow, so they're not performing the role to the same extent as sperm whales, but it's very important nonetheless. And there's a whole group of different kinds of big animals that live in the sea that dive down, get their food deep down, and then come up to the surface and bring up this fertilizer with them. Now, the problem is there aren't as many of them as there used to be. And what you can see here is whale hunting, which took place at an incredible rate from the 17th century right through to the late 20th century. And we slaughtered hundreds of thousands of whales across the world and reduced their populations right down, which meant that this role that the whales play in fertilizing the oceans has got smaller over time. We're also attacking, through our activities, many of the other sorts of animals that live in the oceans and perform these kind of important roles. And 100 million sharks are estimated to have been caught every year. And this is unsustainable, of course. And the net result of all of this fishing activity which is going on, which targets preferentially the biggest animals in the sea, is that the amount of big wildlife in the oceans has declined by something like 70% over the course of the last 200 years or so, which means that the roles that they perform in the oceans have been getting smaller over time. The biological pump is getting weaker, this pump that brings nutrients up to the surface. Now, we are in an era of rapid global change. Carbon dioxide emissions have started to warm up the planet through the greenhouse effect, and this is having an influence on the oceans. And in fact, that influence is very important to us because the oceans have performed a really important role. They have absorbed nearly all of the extra heat which has been trapped by greenhouse gases since the beginning of the Industrial Revolution. So a really large quantity of the heat that would otherwise be in the atmosphere is underwater in the oceans. Now, that's important. In fact, if you had not had this great ocean air conditioner working for the planet, instead of the 1 degree centigrade or so that the atmosphere has warmed up since the beginning of the Industrial Revolution, the temperature above water would have gone up by 36 degrees centigrade. So we'd all be living in Death Valley almost as a result of warming to date. So the oceans have ameliorated our climate, but that has had a big effect on them as well. And the effect, which is most pronounced, is that this surface layer is thicker and more stable. And it's more stable because the temperature difference between the surface and the underlying waters is bigger. And that means that there's less mixing of nutrients up to the surface by physical forces, which means that the biological pump, all of these animals, is a more important part of generating surface ocean productivity. Now, underneath this surface layer, there's another layer of the ocean, and this extends from 200 meters down to about 1,000 meters deep, and it's called the Mesopelagic Zone or the Twilight Zone. So this is where a really weird set of animals lives. And they're important animals, nonetheless. Oh, my microphone's gone again. Anyone know what this animal is? It looks very strange. It's not very familiar to most of us, but it's an octopus, a glass octopus. This is one of the kind of strange creatures that lives in this mesopelagic layer. But there's also something else which is down there, and these are little fish. And this is a species that's called a lanternfish. And the reason it's called a lanternfish is because on its body there are all these tiny little lights which shine in the darkness. And these fish migrate from deep down. They live at about up to 1,000 meters, and they migrate towards the surface at night where they feed. And then they go down during the daytime, deep down. And they're avoiding predators that are active at the surface by coming up at night. Now, there are a lot of these fish in this deep. In fact, what's been estimated recently is there could be as much as 10 times more fish in this deep layer than there is at the surface. And so the majority of fish in the ocean may live in this mesopelagic layer. 10 billion tons of them, which is 10,000 million tons, essentially. And these ones do a different thing. They feed at the surface and poop deep down. So they're taking materials from the surface into the deep sea. And that's really important because they're taking carbon from the surface and locking it away in the deep sea. So this carbon comes from the atmosphere, it dissolves in the surface ocean, and is being moved down into the deep sea and taken out of the planetary system. So they're really helpful in ameliorating the size of global warming. In fact, without these fish, it's estimated that there will be 50% more carbon dioxide in the atmosphere now than there actually is. And so they've spared us a lot more warming from the greenhouse effect. In order to safeguard the planet, we need to look after these fish. We need to look after the connections that underpin the biological processes which make planet Earth habitable. And at the moment, we're not doing a very good job of it. This decline in the big fish is still ongoing in most parts of the world. And there's already interest in exploiting these mesopelagic fish for things like fish meal to feed to the salmon industry. So we really need to do a better job of protecting the ocean, which means fishing less and protecting more. There is a United Nations target at the moment to protect 10% of the sea. We're not there yet. There's something like 6% of the sea which is in any kind of marine protected area. Half of that is protected from all fishing. And we are on track, I think, roughly, to reach 10% by 2020. So that is the good news here. But the bad news is that 10% is not enough. And if you do some scientific calculations about how much we need to protect in order to safeguard life in the oceans, it needs to be something like a third of the ocean area. And so we've got a long way to go. There are new targets being discussed, which would be putting 30% of the sea under protection by 2030. Chile is a global leader in ocean conservation. And taken together, marine parks that have been proposed in Chile constitute something like 38% of the area of ocean controlled as national waters by Chile. So this makes you a really phenomenal global leader in the area of ocean conservation, which is very fitting given that you are a maritime nation, as almost no other is in the world. The job isn't done yet. There's a need for more protection on the continental coast of Chile, but the work is well underway. Thank you very much.